So in this video, we are going to be going over absolute and percent uncertainty, as well as what you do with the uncertainty if you do calculation with it. So when we report uncertainty, it's often going to be reported as the measurement with the unit and then also plus or minus whatever the uncertainty is. So remember, this gives us the range at which the actual measurement should be within. So it can be up or down 0.05 millimeters for this particular measurement. So when you perform calculations, you have to account for every uncertainty in every measurement that you did take. Okay, so with addition and subtraction, it's pretty simple. You're going to actually just add the uncertainties together. So let's say that we're going to be taking the difference in temperature. So we know that the uncertainty for the initial temperature is 0.1. The final temperature, the uncertainty is also 0.1. So if I were to take the difference between these two values, the uncertainty of that change in temperature is actually going to be 0.2. We have to just simply add them together. If we take a measurement by a power, we are going to multiply the uncertainty by that number. So if you square your measurement, you're going to multiply the uncertainty by 2. If you cube it, you're going to multiply the uncertainty by 3, etc. So you're not going to cube or square or take that uncertainty to that power. You're going to just multiply it. All right, multiplication and division. So let's say that you have to multiply your measurement by a constant value. And I'm not saying like Avogadro's constant. I'm just saying that, let's just say you have to multiply your measurement by something like 2, just that number 2. You will multiply the uncertainty by that value as well. Now, if you're multiplying 2 or more measurements together, or you're dividing 2 or more measurements together, you are going to actually use percent uncertainties. So you have to convert them into percentages first. So percent uncertainty. Well, one of the reasons that we use this is because let's say that I want to take a density. Okay, so density is mass and volume. So let's say that I have a mass and the uncertainty of that mass is 0.001. And then we have a volume and the uncertainty is 0.05, but they're in different units, which is why we have to convert this into a percent uncertainty. Now, you have to do this no matter what, even if they're in the same unit. So, and then essentially when you do have a multiplication or division in a series of steps, you're usually changing the units anyway. Okay, so what you're going to be doing, you can't just add these two values together because they're different units. So we're going to hit a percent uncertainty so you have a more usable number. All right, to get your percent uncertainty, you're going to find this by taking the uncertainty and then dividing it by the measurement and then multiplying it by 100. So here, if I wanted the percent uncertainty, that would be 0.1 divided by 5.0 times 100. So that is going to give me 2%. So this would be 0.05 or 5.0 plus or minus 2%. All right, so let's go ahead and calculate out a density and then figure out what to do with the uncertainty. So the first step, so step 1 is to get your percent uncertainties. So let's do that for the mass. That's going to be 0.01 divided by 58.42 times 100. So for this one, I get 0.01711, and I'm going to leave all these numbers here because I'm not going to round anything until I get to the very, very end. And then the volume is going to be 0.1 milliliters divided by 35.1 times 100. So our volume here is going to be 0.289 or 849. All right, so step 2 is add them together. So we add 0.01711 plus 0.2849. And this will give us a total of 0.30201%. All right, so the next step. Well, step 3, do your calculation. So whatever the calculation is. So if we have a density, let's go ahead and calculate that out. So that's mass divided by volume. So 58.42 divided by 35.1. That's going to give me 1.664. And that would get rounded to, there's 4 significant figures here, 3 here, so it gets rounded to 1.66 grams per milliliter. All right, so now we need to get or deal with the uncertainty. So I'm going to erase this. So step 4, we have our density, it's 1.66 grams per milliliter, and this is plus or minus a percentage of 0.30. Okay, so now we're going to put it into absolute uncertainty again. So we know that the percent uncertainty is 0.30201%. So what is that percentage of 1.66? So we're going to take 1.66 and then multiply it by our percentage as a decimal. So divide this by 100. And that gives me 0.00502. Okay. Now, when I'm looking at this, so when I go back and I actually report my final answer, well, I know it's 1.66 for the density, okay? And I know the range is going to be 0.005002. But when I report it, I'm going to go to the significant value place that I have here. So if it goes to 2 decimal places, I'd like my uncertainty to also go to 2 significant figures, or 2 decimal places. And also when we report our uncertainty, the convention is typically just to keep it to 1 significant figure. Now when you do any calculations, you want to actually use the real value of the uncertainty. All right, let's do another calculation. All right, let's do one for specific heat. Okay, so this right here, the 4.186, that does not have an uncertainty value because it's not a measurement, so we don't need to worry about that for the uncertainty. So when we solve for the specific heat, it's just mass times the specific heat capacity multiplied by the change in temperature. So first step is find our percentages. So for our mass, that's going to be 0.001 divided by 130.093. That gives me 0.000766868. All right, so let's do this for temp. So our uncertainty is 0.2 divided by the measurement. And that will give us 0.5333. All right, so now step 2, we're going to add them together. So 0.0076868 plus this. right? It's going to be 0.53341. All right, so the next part, step 3, well, the calculation's already done for you. It's 20.4, and that's also rounded to the correct number of significant figures, which is 3. So now let's go ahead and take this 20.4 and multiply it by our percentage as a decimal. So 0.53341 divided by 100 times that will give me 0.10895 kilojoules. All right, so last step, just make sure it looks appropriate in rounding. So it's going to be 20.4 kilojoules plus or minus, and well, the first decimal place here is 0.1, and that won't get rounded up because it's got a 0 behind it, so it's 0.1.